And now in this lecture we'll find out the length of line segment PQ is equals to x. We have to find out the value of x. In the drawing we have a semicircle. We know that this is line segment QS, that is equals to 2 units in its length. This is line segment SV, that is equals to 1 unit. This is angle PQS, that is a right angle. This is angle PTS, that is also a right angle. And we also know that PT equals to TS. Our task is to find out the length of this line segment PQ, that is equals to x. We have to find out the value of x. So first of all, we complete the semicircle to a circle. We completed the semicircle to a circle, and we will extend line segment TS by a straight line until it touches the circle. We define the touching point of the extended line segment TS with this circle. This point is point M. In the next step, we will join points M and P together by straight line. When doing all those constructions, we created here triangle PTM. Triangle PTM is a right angle. It is equal to 90 degrees in size. And according to rule 5, any peripheral angle that is equal to 90 degrees in its size must subtend on the diameter of the circle. So please quickly on rule 5. Again, according to rule 5, any peripheral angle that is equal to 90 degrees in its size must subtend on the diameter of the circle, and therefore peripheral angle PTM, that is a right angle, subtend on chord PM, and therefore PM must be the diameter of the circle according to rule 5. So I write it down. If you found out that PM is the diameter of the circle according to rule 5. We know it is given us in the question that point O is the center of the circle, point P is the point on the circle itself, therefore OP is the radius of this circle. We know that OB is of course also the radius of the circle. OB equals to 2 plus 1. Again, OB in total equals to 2 plus 1, and therefore the diameter of the circle is equal to 3 units. Therefore, again, the radius OB equals to 2 plus 1, and therefore that is 3. Therefore the radius of this circle is equal to 3 units in its length. So the radius OP is equal to 3 units in its length. The radius OM is also equal to 3 units in its length. In the next step, we will do a construction, that is to say, from this point S, we will draw perpendicular on OM. Again, from point S, we will draw perpendicular on OM or PM, it is the same. From point S, we will draw perpendicular on OM. So if this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point S and 90 degrees to OM. This point is point N. The radius OM equals to 3 units in its length. Again, we will define the touching point of the perpendicular from point S and 90 degrees to OM. This point is point N. In the next step, here we know that those two angles are defined as vertex angles, and we know that vertex angles are equal to each other. That is to say, angle NOS equals to angle QOP, because they are vertex angles and they are equal to each other. So if we define the size of the vertex angle NOS as alpha, then the size of this vertex angle POQ must be also equal to alpha, because they are equal to each other. So in the right angle PQO, we have, this is angle alpha, this angle equals to 90 degrees, according to what is given in the question. And therefore this first missing angle must be equal to 90 degrees minus alpha. 1 equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in a triangle. Likewise, in the small right triangle SNO, this angle equals to alpha. This angle equals to 90 degrees, and therefore this vertex angle must be equal to 90 degrees minus alpha. Again, because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles that is the sum of the angles in a triangle. In the next step, we'll prove that the right triangle PQO is similar to the small right triangle ONS according to angle similarity rule. It is very easy to see it from the drawing, but I will prove it anyway. So why the right triangle PQO is similar to the right triangle SNO? First of all, those two angles, the vertex angles, they are equal to each other. In addition, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees, and therefore they are equal to each other. So if you found out that all the fingers of the right triangle PQO are correspondingly equal to all the fingers of this right triangle SNO, and therefore those two right triangles are similar to each other according to angle similarity rule. So write it down. If you found out that the right triangle PQS is similar, this is the sign of similar to the right triangle ONS, this for right triangle ONS, according to angle similarity rule. And for the fact that the right triangle PQO is similar to the right triangle SNO, we will derive that the following relationship exists between their sides. We will derive that side NS of the small right triangle NSO, or side PQ of the upper right triangle PQO, is equal to side OS of this small right triangle ONS over side PO of the upper right triangle PQO. And again, from the fact that the right triangle PQO is similar to the small right triangle NSO, we derive that the following relationship exists between their sides. We derive that side NS of the small right triangle NSO or side PQ of the upper right triangle PQS is equal to side OS of the small right triangle ONS or side PO of the upper right triangle PQS. NS is the missing side, so we leave it as it is. Over PQ. PQ is the line segment that we are looking for in this question, and it is equal to x. We have to find out the value of x, and it is equal to OS according to what is given us the question. OS equals to 2 units in its length. Over PO. We have already found out that PO is the radius of this circle that is equal to 4 units in its length. So in total, we have found out that NS over X equals to 2/3. Again, NS over X equals to 2/3. Here we multiply this equation by X. X definitely cannot be equal to 0 because X is a length. It must be a positive number. So it is allowable to divide the equation by X. So NS equals to 2/3 X. NS equals to 2/3 X. In the next step, we will define this angle M as beta. So in the right triangle PMT, this angle equals to beta. This angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees, if you focus on the right triangle PTM, 90 degrees minus beta plus beta is 90 degrees. 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, in this small right triangle NSM, this angle equals to beta. This angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus beta. Again, 90 degrees minus beta plus beta is 90 degrees. 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. Actually, it is very easy to see that the big right triangle PTM is similar to the small green right triangle NSM. I'll prove anyway why the big right triangle PTM is similar to this small green right triangle NSM. So, first of all, this is angle beta. That is a common angle that belongs to both triangles. So you can write down that angle beta equals to itself as a common angle that belongs to both triangles. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus beta and therefore they are equal to each other. So I should find out that all the figures of the big right triangle PTM are correspondingly equal to all the figures of this small right triangle NSM. And therefore those two right triangles are similar to each other according to angle similarity rule. So I write it down. We actually found out that the big right triangle PTM is similar. This is the sign of similar to the small green right triangle NSM. According to angle similarity rule. And from the fact that the big right triangle PTM is similar to this small green right triangle NSM, we will derive that the following relationship exists between their sides. We will derive that side NS of the green small right triangle NSM over side PT of the big right triangle PTM is equal to side SM of the small green right triangle NSM over side PM of the big right triangle PTM. And again, from the fact that the big right triangle PTM is similar to the small right triangle, the small green right triangle NSM, we derive that the following relationship exists between their sides. We derive that side NS of the small green right triangle NSM over side PT of the big right triangle PTM is equal to side SM of the small green right triangle NSM over side PM of the big right triangle PTM. We have already found out that NS equals to 2/3 X to divide it by PT. What is the length of PT? PT, we know that it is given us the question that PT equals to TS. Again, PT equals to TS according to what is given us the question. We define the length of line segment PTSA. Therefore, TS must be also equal to A because they are equal to each other according to what is given us the question. So, according to our definition, PT equals to A. So we substitute PT by A, and it is equals to SM. What is the length of SM? SM is the missing side, so we leave it as it is, over PM. PM is actually the diameter of the circle. The radius is 3, therefore the diameter must be equal to 6. You can see it from the drawing itself that PM equals to 3 plus 3, that is 6. So in total, we actually found out that 2/3 X over A equals to SM over 6. Here we will cross multiply this equation, and we get that 2/3 X times 6 equals to ASM. So of course multiply the equation, and we found out that 2/3 X times 6 equals to 8 times SM. 6 over 3 is 2, and 2 times 2 is 4. So in total, in this side of the equation, we left only with 4x. This is equation 1. So according to equation 1, we have here in this side of the equation 1, 4x equals to ASM. 8 times SM. Repeat again, if we found out that according to equation 1, x equals to 8 times SM. Here we can implement a rule that we already talked about it in the previous lessons. So here, if we have a circle, in this circle we have chord AB. This is chord AB that intersects with chord CD. This is chord CD. And they intersect with each other in this point O. Again, yep, a rule that we already talked about it in the previous lessons. Only to this rule, if we have chord AB that intersects with chord CD at point O, so in this domain, the following equation is true. That AO times OB equals to CO times OD. And again, we have the line a circle. Inside the circle we have chord AB that intersects with chord CD at point O. Point O is the intersection point of chord AB with chord CD. In this domain, the following equation is true. That AO times OD equals to CO times OD. Again, AO times OB equals to CO times OD. We can implement the new rule, the rule that we already talked about it previously in our drawing. Well, because in our drawing, this is chord TM, chord TM intersects with chord AB. This is chord AB. Chord TM intersects with chord AB, and the intersection point occurs at this point S. Repeat again. In our original domain, we have chord TM intersects with chord AB at point S. Again, chord TM intersects with chord AB at point S. Point S is the intersection point. So according to the rule that I presented to you, the following equation is true. That TS times SM equals to AS times SB. So I define the rule as rule 15. According to rule 15, now I'm drawing, because of the fact that chord TM intersects with chord AB at point S, the following equation is true. That TS times SM equals to AS times SB. Again, according to rule 15, the following equation is true. That TS times SM equals to AS times SB. TS equals to A according to our definition times SM. SM is the missing side, so we leave it as it is. So in this side of the equation we have A times SM. This will be equation 2. A times SM equals to AS times SB. What is the length of this times AS? AS equals to AO times OS. Again, AS in total equals to AO plus OS. So AS equals to AO, that is the radius of the circle that is 3, plus OS that is 2. So in total, AS equals to 3 plus 2, that is 5. So AS equals to 5 units in its length. times SB. SB equals to 1 unit in its length according to what is given us the question. So in total, we found out that according to equation 2, A times SM equals to 5 times 1, that is 5. Again, according to equation 2, A times SM is equal to 5. This is according to equation 2. But according to equation 1, we have already found out that A times SM is equal to 4x. So in the next step, we create equation 3 that states that A times SM according to equation 1 must be equal to A times SM according to equation 2. In this equation 3, A times SM according to equation 1 must be equal to A times SM according to equation 2. A times SM according to equation 1 is equal to 4x. A times SM equals to 4x. A times SM equals to 4x. A times SM equals to 4x. And it must be equal to A times SM according to equation 2. A times SM according to equation 2 is 5. So in total, if you found out that according to equation 3, 4x equals to 5. Here we will divide this equation by 4 and finally we get that the missing line segment A, the missing line segment PQ that equals to x. PQ is equals to x is equal to 5 over 4 units in its length. In terms of numbers, it is equal to 1.25 units in its length. And again, we should found out that the answer to the question is that the length of this short line segment P cubed is equal to x. It is equal to either 5 over 4 units in its length, or in terms of numbers, it is equal to 1.25 units in its length. So in the next step, I'll summarize the lecture. Our task in this question is to find out the length of this short line segment PQ that is equal to x. We have to find out the value of x. So in the drawing we have a semicircle. We know that this is line segment OS that is equal to 2 units in its length. This is line segment SB that is equal to 1 unit. This is angle PQS that is a right angle. This is angle PTS that is also a right angle. Again, our task is to find out the length of this short line segment PQ that is equal to x. We have to find out the value of x. So first of all, we did a construction. We completed this semicircle to a circle, and we extended line segment TS by a straight line until it touches the circle. We define the touching point of the extended line segment TS with this circle. This point is point M. In the next step, we join points P and M together by a straight line. By doing all those constructions, we can do peripheral angle PTM. According to what is given in the question, peripheral angle PTM is a right angle, it is equal to 90 degrees in size, and peripheral angle PTM subtend on chord PM. Again, peripheral angle PTM subtend on chord PM. And according to rule 5, any peripheral angle that is equal to 90 degrees in size must subtend on the diameter of the circle. Peripheral angle PTM equals to 90 degrees, and it subtends on PM. Therefore, PM must be the diameter of the circle according to rule 5. Again, PM is the diameter of the circle according to rule 5. It is given us the question that point O is the center of the circle, So point P is the point of the circle itself, therefore OP is the radius of the circle. The radius of the circle is also OB. OB equals to 2 plus 1, that is 5. So if you found out that the radius of this circle, again, OB equals to 2 plus 1, that is 3. The radius OB equals to 2 plus 1, that is 3. So the radius OP equals to 3, and the radius OM also equals to 3 units in its name. In the next step, we did a construction. That is to say, from this point S, we draw perpendicular on PM. Again, from point S, we draw perpendicular on PM. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point S and PM. This point is point N. So here we defined the length of, here we have actually those two angles are defined as vertex angles, and we know that vertex angles are equal to each other. So if we define the size of this angle as alpha, then the size of this angle must be also equal to alpha because they are equal to each other. So in the right triangle PQO, this angle equals to alpha, this angle equals to 90 degrees, and therefore this vertex angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, 90 degrees plus 90 degrees, it is equals to 180 degrees, that is the sum of the angles in a triangle. Likewise, in the right small triangle O and S, this angle equals to alpha, this angle equals to 90 degrees, and therefore this vertex angle must be equal to 90 degrees minus alpha. So it is very easy to see that those two right triangles are similar to each other according to angle similarity rule. That is to say, the upper right triangle PQO is similar to the lower right triangle ONS according to angle similarity rule. So I will explain anyway why those two right triangles are similar to each other. First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees, and therefore they are equal to each other. So if you found out that all the figures of the upper right triangle PQO are correspondingly equal to all the figures of this lower right triangle ONS, and therefore those two right triangles are similar to each other according to angle similarity rule. Repeat again, if you found out that the right upper triangle PQS is similar, this is the side of similar to the lower right triangle ONS according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side NS of the small right triangle NSM over side PQ of the big right triangle PQO is equals to side OS of the small right triangle ONS over side PO of the big right triangle PQO. So again, we write that side NS of the small right triangle ONS over side PQ of the right triangle PQS is equal to side OS of the small right triangle ONS over side PO of the upper right triangle PQS. NS is the missing side, so it is PQ is X, OS is 2, and PO is 3. This is the radius of the circle, that is 3. So in total, we actually found out that NS over X equals to 2/3. Here we multiply this equation by X and finally found out that NS equals to 2/3 X. 2/3 times X. So this is the missing side NS, that equals to 2/3 times X. Okay, so in the next step, we define this angle M as beta. And again, we define this angle M as beta. So, and we focus on the big right triangle PTM. On the big right triangle PTM, this angle equals to beta. This angle equals to 90 degrees, and therefore this vertex angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees, that is the sum of the angles in a triangle. Likewise, in the green small right triangle NSM, this angle equals to beta. This angle equals to 90 degrees, and therefore this angle must be equal to 90 degrees minus beta, according to the same rule. It is very easy to see that the big right triangle PTM is similar to this small green right triangle SNM according to angle similarity rule. So I prove anyway why the big right triangle PTM is similar to this small green right triangle NTM. First of all, this is angle beta. That is a common angle that belongs to both triangles. So can I know that angle beta equals to itself is a common angle that belongs to both triangles. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, both those two angles are both equal to 90 degrees minus beta, therefore they are equal to each other. So if you found out that all the figures of this big right triangle PTM are correspondingly equal to all the figures of this small right triangle NSM, and therefore those two right triangles are similar to each other according to angle similarity rule. So if you found out that the big right triangle PTM is similar to the small green right triangle NSM according to angle similarity rule. And from the fact that the big right triangle PTM is similar to the small right triangle NSM, we derive that the following relationship exists between their sides. We derive that side NS of the green small right triangle NSM over side PQ over side PQ of the right big. We derive that side NS of the small right triangle NSM over side PQ of the. Now we are talking about triangle, the big right triangle TMP, that is similar to this small right triangle NSM. So why those two right triangles are similar to each other? We actually proved that those two right triangles are similar to each other, and because of the fact that they are similar to each other, the following relationship exists between their sides. We derive that side NS of the small green right triangle NSM over side PT of the big right triangle PTM is equal to side SM of the green right triangle NSM over side PM of the big right triangle PTM. And again, we derive that side SN of the small right triangle NSM over side PT of the big right triangle PTM is equal to side SM of the small green right triangle NSM over side PM of the big right triangle PTM. We have already found out that SN equals to 2/3 X over PT. PT equals to A, according to our definition, and it is equals to SM. SM is the missing side, so we leave it as it is, over PM. PM is the diameter of the circle, that equals to 6 because the radius is 3. So PM equals to 6. So in total, we found out that 2/3 X over A equals to MS over 6. Here we cross multiply this equation, and we found out that 2/3 X times 6 equals to 8 times MS. Again, 2/3 X times 6 equals to 8 times MS. Here 6 over 3 is 2, and 2 times 2 is 4. So in total, in this side of the equation, we have 4x equals to 8 times ms. So according to equation 1, we have found out that 4x equals to 8 times ms. In the next step, I actually presented to you rule 15, that we already talked about it in the past. And we implemented rule 15 in our drawing. Rule 15 is true in any circle, so we have here a circle that could be any circle. And we have inside the circle we have chord AB that intersects with chord CD at point O. Again, chord AB intersects with chord CD at point O. So in this drawing, the following equation is true. That AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can actually implement the new rule in our drawing. Why? Because in our drawing we have, this is called Tm, that intersects with code AB at point S. Again, code Tm intersects with code AB at point S. Code Tm intersects with code AB at point S. And therefore, the following equation will be true, that Ts times Sm equals to As times Sb. Again, Ts times Sm equals to As times Sb. Again, if you found out that according to rule 15, Ts times Sm equals to As times Sb. Ts equals to A times Sm. Sm is the missing side, so we leave it as it is. So in this side of the equation 2 we have A times Sm, and it is equals to As. As in total is AO, that is the radius, that is equals to 3, plus OS, that is 2. So in total AS equals to 3 plus 2, that is 5. AS equals to 5 times SB. SB equals to 1 unit in itself according to what is given in the question. So in total we found out that A times Sm equals to 5 times 1, that is 5. OA times Sm equals to 5. According to equation 2, we found out that A times Sm equals to 5. Well, according to equation 1, we found out that A times Sm equals to 4x. So in the next step, we created equation 3, that states that A times Sm according to equation 1 must be equal to A times Sm according to equation 2. A times Sm according to equation 1 is 4x, and it must be equal to A times Sm according to equation 2. A times Sm according to equation 2 is 5. So in total according to equation 3, we actually found out that 4x equals to 5. Here we divided this equation by 4, and we found out that x, this is x, line 7 PQ, that equals to x. In total it is equals to 5 over 4 units in its length in terms of numbers. PQ that is equals to x is equal to 1.25 units in its length. Okay, thank you very much.